So right here we have solving rational equations. You can see that all of these are fractional terms. So you've got a 2 over 3x, you've got a 1/4 and a 1 over 6x. The important thing is that there are variables in the denominator. You can see on example 2, there's variables in the numerator too, but it's important that at least one of them has a variable in the denominator for it to be considered a rational fraction. So the first thing we always want to do is we want to look at these denominators here and decide what the LCD will be. So in this case, the LCD, because at least one of them has the variable x, then we need to have an x in there. And then we want the smallest number that 3, 4, and 6 go into. So if we look at 3 times 4, that's 12. Does 6 go into 12? It does. So then that means our LCD will be 12x. So what we're going to do with that LCD is we will multiply each term by 12x. So I'm going to rewrite the original equation. Okay, and what we're going to do here is we're going to multiply each term by 12x. And notice I'm not trying to get a common denominator in here. What I'm actually trying to do, if I multiply everything by the LCD, when I'm done with this, we won't have a denominator at all. So when I do this math, we can see this multiplication gives us 12 times 2 is 24x over 3x, which is equal to 12x over 4 minus 12x over 6x. We can see here that these will simplify. 3 goes into 24 8 times and the x cancels off. 4 goes into 12 3 times, so we get a 3x, and then we have 12x divided by 6x, which is equal to -2. And now we have a simple equation that we have to solve. To solve this, just use our linear skills, and we can add 2 to both sides, and we'll get 10 is equal to 3x. Finally, we can divide by 3 on both sides, and we get that x is equal to 10 over 3. We can always go back and check our work. I would suggest doing this with a calculator. On example 2, we have denominators such that x minus 3, and we have a 2. So that means the LCD will be 2 times x minus 3. I'm going to solve this problem on the second half of my paper, so I have space. I'm going to rewrite the original problem. X over x minus 3 is equal to 5 over x minus 3 minus 2. Okay. So here what we're going to do is we're going to multiply each of these terms by 2 times x minus 3. Again, that way we won't have any denominators. I'll show you a different way to do this, which is a little bit easier. Is we can cross off any terms that are now in the numerator and the denominator. So I multiplied by x minus 3, it will divide out the denominator, so that leaves us with a 2x. We can get rid of this x minus 3 in this term, and now we have 10. 5 times 2 is 10, minus these 2's cancel. A -1 times x minus 3. I'm going to have to distribute that -1, which gives us 2x is equal to 10 minus x plus 3. We can combine like terms, giving us 2x is equal to 13 minus x. Let's add x to both sides, which gives us 3x is equal to 13. And then finally we can divide by 3, giving us x is equal to 13 over 3. All right, there you have it. All right, Our last example is going to require us to do a little bit more work in order to find our LCD. The first thing we have to do is factor x squared minus x minus 2. This is something you should be able to do already. If you don't have this skill, then I'm going to put some links on the video for you that you can click on them and you can review your factoring skills. But one way some people do this is using the AC method. In the top, we always multiply a times c. In the bottom, we put b. We're looking for two numbers that multiply to a times c that add to b. And so here we have an imaginary 1 in front of this x squared minus x minus 2. So that means in the top, we have 1 times a negative 2, which is negative 2. On the bottom, we've got a negative 1. And now we are looking for two numbers that multiply to negative 2 that add to 1. Those numbers would be negative 2 and 1. This factors to x minus 2 times x plus 1. So, looking at all the LCDs here, we have x minus 2, x plus 1, we have x minus 2 times x plus 1. So, the LCD will be x minus 2 times x plus 1. And we will then rewrite this equation. Notice when I rewrite it, I'm going to leave the denominator factored, and now we will multiply by the LCD, which is x minus 2, x plus 1, 2x plus 1, x minus 2, x plus 1, and then we will cross off any terms that we will find in the top and the bottom. Notice this is really like 2 times x minus 2 times x plus 1 in the top now, so these x minus 2's cancel off. We will have left over 2 times x plus 1. On the second term, the x plus 1's will cancel off, giving us 1 times x minus 2. And on the back, the x minus 2 will cancel, the x plus 1 will cancel. That does not mean everything goes away because that's really like a big fat 1 right there, and so that gives us back 1. Now we can distribute 2x plus 2 plus x minus 2 is equal to 1. Combine like terms. I've got a 3x is equal to 1. Notice plus 2 and minus 2 cancel out, and then my final thing, I will divide by 3, giving me x is equal to 1/3. One thing you should note when you're doing this is you want to pay attention. Make sure the answer to x will not make your denominator equal to 0. We haven't talked about domain yet in this class. However, when we do, it will become a problem, and we will discuss that later.